Hello and welcome. Here we would like to find the domain of several functions. And the first example we are having here is I'm referring to it as if we have a 0 in the denominator. Now, if you look at this function and you try to find the domain, if you remember the domain, it's the numbers that I can use inside these functions without creating any problems. Now, if we look at this particular example, we need only to be worried if there is something equal 0 in the denominator. So we need to avoid having 0 in the denominator. So in this equation, the domain of the function will be all real numbers, everything is fine, except if the denominator is 0. So the idea, what we will do now, we will find where is the denominator is 0, and we will exclude that number. We will take it off. We don't want to see it. So what we will do here is we will solve this equation. We will write denominator equal to 0. Of course, after that, we will exclude the answer. So, what is the denominator? If you look at this equation, the denominator is x negative 1 equal to 0. So how much the value for x? The value for x equal to 1. Remember what we will do? We will exclude it. That's the idea. So we'll exclude the number. Now, what do I mean by exclude the number? That's it. The domain is all real numbers, everything except x equal to 1. In another word, we can just write it as the final answer. We can just write it as x not equal to 1. So that's the values for x. So the idea, if we have 0 denominator, we make the denominator equal to 0. Whatever the answer we got, we just exclude it. Now, can we write the answer like this? No, we have to write the answer the same way we did for inequality, which means we have to write it as set notation. If you remember set notation, we open bracket, we close bracket, we write x, and then we write a line here. And in this side, you write your description. What is your answer? And remember, my answer after the exclusion, x not equal to 1. That's the first one. Second, you need to write it as a number line. What do we mean by number line? Of course, we need to shade somewhere. Now, this is 1. Where should I shade if I'm saying x is not equal to 1? Of course, you will shade the right side. You will shade the left side because those are not equal to 1. And at 1, I'm already excluding 1, so I will write it as open circle. So if we shade here, I'll shade this side. I'll shade this side. And exactly at 1, I'll just write it down as open. Finally, we need to write it as an interval. So look at this piece here. I start from negative infinity to 1. Of course, 1 is open because it's not included. And then I continue from 1 to infinity for this piece. So I have my answers are 2 pieces. I will write the interval for each piece, and then you will join them by this sign, which we call it union. Keep in mind, if we have 2 pieces in the number line, the way to join them is by putting a union. And that's exactly what we get as final answer for this question if x is not equal to 1. Now, the next example is, or the next type of problems. So the first type of a problem, if we have denominator, now we know how to deal with denominator. We just make the denominator equal to 0 and then exclude it. Now, what happens if we have a square root or a fourth root or a sixth root? So I will refer to it as negative inside even root. What shall we do with this one? This is straightforward. What we need to do is directly, so the domain is all numbers that makes the inside of the root non-negative. So either positive or 0. So how we will solve it? We will go directly and we will take whatever inside the root and we will make it greater than or equal to 0. Directly. That's straightforward, no exclusion. And this will only work if we have even root. If we have a cubic root, there is no problems. Positive, negative, everything will be in the domain. Now I'm just talking about the even root. Now what is inside the square root is 2x negative 4 greater than or equal to 0. And now this is inequality. And we know how to solve inequality. We take the 4 to the other side. So I get 2x divided by 4. Now we have to divide by 2 both sides. So what do we get? We get x greater than or equal to 2. And that's the answer. And because this is inequality, we know how to do it as number line, we know how to do it as interval, and as a solution set. So let me go to the next page and write my final answer as a solution set. So I will write x such that x is greater than or equal to 2. Now in the number line, this is 2. Where should I shade if I'm talking about x is greater than or equal to 2? Greater than or equal to 2 are the numbers that are bigger than 2. They are to the right. So I will shade here in this area. And exactly at 2, I will just make a big shade like this because 2 is included because I have this greater than or equal. And finally, as an interval notation, if you look at my shading, I start at 2, I end up at infinity. Infinity, of course, it should be open, and at 2, it should be closed. So this will be my final answer for this question. So this is the second type of problems that we have for the domain. Denominator and square root. Well, let's see the third type of problems. Which will be 2 together. I have 0 denominator and negative inside the root. So you have to deal with each one separately. What do I mean by each one separately? Let me just divide it into 2. First, you have something in the denominator. 0 denominator, deal with it. I will deal with something in the denominator. Now, what do we do if we have something in the denominator? We write denominator equal to 0, and then we exclude. Remember, at the end, we will exclude. Now, what do we have denominator equal to 0? We have square root x negative 4 equal to 0. How we get rid of the square root? We just square both sides. We get x negative 4 equal to 0. That means x equal to 4. And remember, we need to exclude this one. So finally, from this side, x not 4. Anything is fine. don't use 4. That's for the 0 denominator, because we remember we have a problem that we have a whole denominator here. Now the second problem in this question, which we also need to take care of, is we have a root. How we deal with something like a root? Well, we deal with it in that way. Let me use purple here. For the root, whatever inside the root should be greater than or equal to 0. Now, what is inside the root? It is x minus 4 greater than or equal to 0. That means x greater than or equal to 4. Now, we have two solutions. We need to combine them. Now, if we combine them, this one, x greater than or equal to 4. This one, just x not equal to 4. So if you combine them, the combination will be that x is only greater than 4. And that's the answer, because we are comparing them. In one side, I'm saying x is 4 and above. On the other side, I say I don't like 4. So it will be just above 4. And next, you just do it the same way by having the solution set. Now, the solution set will be just x such that x greater than 4. If we do it in the number line, this is 4. We only shade where it's greater than 4, which is this side. Should we include 4? No, because it's only greater than 4. And finally, if we do it as an interval, we start my shading from 4. I end my shading at infinity. Always at infinity, it's open. And at 4, because I start at 4, it's also open. And that's the solution for this question. So sometimes we have more than one problem. We need to deal with them, and then we need to combine them together. Now, let's look at this example. This is a very nice example because here I can see two problems. Can you see those two problems? Think about it for a second. Now, what are those two problems I'm referring to? First of all, I have this square root. So that's the first problem. And then I have also another square root. So I need also to divide my page into two. First, I have the first problem as this root. I deal with this. And then I have another problem, which is this root. Let's see how we deal with this one. Well, with this one, directly, I write inside greater than or equal to 0. So this means 2 minus square root of x greater than or equal to 0. That means if I move the square root to the other side, this means 2 is greater than square root of x. Now, if we want x alone, we square everything. So that means x is less than or equal to 4. That's the first part. Inside is greater than or equal to 0, and we separate x. Now for the second part, which let me do it in purple. Well, we have only inside must be greater than or equal to 0. And what is inside greater than or equal to 0? It is actually x greater than or equal to 0. And that's the only thing I have. So in this side, I have x greater than or equal to 0. In this side, I'm saying x is less than or equal to 4. Now, let me go ahead and do them on the number line and see exactly where they will be shared. Now, let's do it here. So in this case, I have x such that x is less than 4, and from the purple side, x is greater than or equal to 0. Now, if we try to do them in the number line, first I will do the orange one, which is, this is 4. Where should I shade for the orange one? X is less than or equal to 4. So just like this, and then I should share this side. That's for the orange one. Remember, for the purple one, you start from the 0. Of course, the 0 should be somewhere here, and again like this, and then you have to shade to the right. Now, if you look at this picture, where the two colors overlap, they overlap here. So this is my solution. This is my only acceptable answer. So in this case, I will just erase everything. Okay, I'll just erase this side here, and I will erase this side here. And that's the final solution. Final answer. Which means you will start at 0, you will end up at 4, 0 is included, 4 is included. And that's how we solve this question. If you have any question or concern, please write me.